Now, as far as systems of equations goes, this is about as easy as a system of equation can get. Does anybody know what y is? Oh, it's 2. So if you know what y is, how would you find x? Well, you just go and plug in 2 for x, right? And then you get x plus 2 times 2 equals 3. So x is equal to -1, and we've solved our solution. Now, we can take our equations that we have there and make something called an augmented matrix. So an augmented matrix is the same matrix that you had. In fact, if you were going to type this into your calculator, it has 2 rows and 3 columns. So it'd be a 2 by 3. And if you have this one where the equal sign is, we just draw a straight line to show that on the left was where you had your x's and your y's, and on your right you had your solutions from before. And if you get an augmented matrix like this where there is a 0 here, well, that means you've already solved for y. And then if you've already solved for y, you can plug it back into the other equation, and then that would let you solve for x. And if you get zeros in the bottom left corner, it's called row echelon form. And what we're going to learn today and in the next class is how we can reduce our original matrix to get it into this form where we have zeros in the corner. And you can do it for any size square matrix. And work your way down until you have zeros in the corner. And then once you've got the zeros in the bottom left-hand corner, you will know what one of the variables is. And this is called Gaussian elimination. It's basically the same thing that you do with substitution and elimination, but it allows you to work with a matrix rather than working with a bunch of equations all at the same time. So what you're going to do, you're going to take your equations and make an augmented matrix. And then we're going to call something elementary row operations, which are basically the same thing you did with elimination to get zeros in the bottom left-hand corner. For example, if you had the following equation, 2x plus 3y equals 8, and x plus 5y equals 11. And you were going to use elimination to solve this, what would you do first? Would you like to eliminate the x's or eliminate the y's? What looks easier? X's. And you would take equation 2 and multiply it by 2. Or -2, right? Either one. So if we multiply by 2 or -2, then we've still got our first equation. And our second equation would look like this. Adding those equations up, you would get -7y equals -14. And then you'd be able to solve it. What it's going to look like for us here, just feels good to write that down. Okay, what it's going to look like for us with an augmented matrix is instead of writing down all of our numbers, we're going to have 2, 3, and 8. And we're going to have 1, 5, thank you. I don't know where I was looking. 1, 5, and 11. And we're going to say, we're going to change row 2. I'll do R2 for that. And the way that we're going to change it is we're going to change row 2 by multiplying by a number and adding it to another row. So what we did with our elimination here, what did we do? We took row 2 and we multiplied row 2 by -2. You're allowed to do that because that doesn't change what it's equal to. And then once you've done that, you're going to add it to row 1. And that's a bigger one than I wanted it to be. Here we go. A little one. So if I took row 2 and multiplied it by -2 and added it to row 1, I'm only changing row 2. So the first thing I could do is I could say 2, 3, and 8 are going to stay the same because I'm not changing those. But when I multiply this by -2 and add it to this, I'm going to get 0. Okay, -10 plus 3, -7, -22 plus 8, -14. And it shows the exact same thing that we got with our elimination. The only difference is we don't have to write down as many x's and as many y's. It also doesn't matter how you write it. So we could take this same equation. Sometimes life is easier when you're dealing with ones in the top right-hand corner. So I could have this same thing written this way, 2, 3, and 8. Okay? And then I could say, well, to me it's easier to multiply this and add it to this one. So I could change row 2 to equal row -2 times row 1 plus row 2. See, that's sort of the same thing I did last time. But now my row 1, which I had originally, which was 1, 5, and 11, that's the one that's not changing. And if I multiply this by -2 and add it, I'm going to get 0. -10 plus 3, -7, -22 plus 8, -14. So you get the same results if you work with one equation or the other. And as soon as you get a 0 in the bottom left-hand corner, it's going to call that reduced echelon form. And then from there, you can say, well, now that I got a 0, -7y is equal to -14. So I know that y is 2. And once I have y is 2, I can go to my other equation, which is x plus 5y's equals 11. So x is equal to 1. And we can solve it completely from there. So let's do one more example together. Our goal is to get a 0 there. What could we do to row 2 to do that? Multiply it by -1 and add them. Could do that. Or we could just subtract them, which would be the same thing, right? So, and which one? Do you want to do row 1 subtract row 2 or row 2 subtract row 1? Can you see that either way that you do that, you'll get a 0? Which one do you feel is, want to do the first one minus the second one? You're working down? I like that better too. Row 1 minus row 2. If I take row 1 and minus row 2, well, my row 1 is staying the same. 1 minus 1, of course, is 0. -2 minus 4 will give us -6. 10 minus 16 will give us -6. So now we know that -6y equals -6. So y is equal to 1. And if we plug back into our first equation, 1x minus 2y equals 10. X is equal to 12. And if we check both of those by plugging them back into the original equation, they work. So I'm going to let you try the next couple, and then we'll do a 3 by 3. I will come back to the 3 by 3 in a second. So this first one, 4 and negative 5, x is 4, y is negative 5. Just 5? Oh, that's a plus sign anyways, good. This one, what do we get for x? Minus 1, and y minus 5. And finally, the last one, x, 2, and y, 5. Okay, so if you didn't get those, I'll come around and check to see where your mental math mistakes may have been. The first one was 4 and 5. Now, try the 3 by 3, and your goal is to eliminate it down to zeros in the bottom left-hand corner. And then we'll do a 70 by 70. No. So here's our 3 by 3. Our goal is to get zeros in the bottom left-hand corner. Some things that I find helpful is this row with all the 1s and the 4. It's very easy to multiply that row by stuff and add it and subtract it because they're all 1s. So the first thing I'm going to do as an operation is I like the thing that I can manipulate the most in my row 1. So I'm just going to interchange row 1 and row 2. I'm just going to switch them. Because that wouldn't make a difference in my series of equations, just means I wrote them in a different order. So this is going to be easier for me to work with. 1, 1, 4, 3, 2, negative 4, negative 20, and 5, negative 1, 1, 18. So that's going to be easier to work with. Now, my first thing I'm going to do is get these two zeros. So to do that, and I'm going to do them both in the same equation, I'm going to change my row 2 and I'm going to change my row 3. I'm going to keep my row 1 the same. So I may as well just rewrite it 1, 1, 1, 4. My row 2 is going to equal, and I like to always start with the row that I'm changing. I'm going to take row 2 and subtract 3 row 1s. Can you see that if I took row 2, which is a 3, and subtracted 3 row 1s, I'm going to get a 0 here. And if I take 2 and subtract 3 row 1s, I'm going to get a negative 1 there. And negative 4 subtract 3 row 1s is negative 7. And negative 20 minus 3 times 4 will give me negative 32. And my row 3, I'm going to take my row 3 that I had and subtract 5 row 1s. Because if I take what I have and I subtract 5 row 1s, I'm going to get 0. Negative 1 minus 5 give me negative 6. 1 minus 5 give me negative 4. And 18 minus 5 times 4, negative 20, will give me negative 2. So my goal, I'm able to get all the zeros in my first column that I want. Now I just need one more column to do. I need to get my row 3. Can you see that if I take row 3 and now subtract 6 row 2s, because if I multiplied row 2 by a negative 6, I'd get a positive 6 here, and then adding those will give me a 0 where I want it to. I'm not going to change row 1 or row 2 this time, so I can rewrite them. 1, 1, 1, and 4. 0, negative 1, negative 7, and negative 32. And now, the reason why it's nice to have these zeros in that first column is because when I multiply 0 by negative 6, I still get 0. And add it to 0 will still give me the 0 there. And now negative 6 minus negative 6 times negative 1 will give me 0 there. Negative 4. If I times this 7 by negative 6, I'm going to get 42. And the negative 4 will give me right? 38, because 42 minus 4, 38. And here, when I multiply negative 132 by negative 6, will give me positive 192. Plus the negative 2 will give me 190. Got some big numbers. But now, that means that our row 3 says 38 times z is 190. Divide by 38, and you get 5. Now we can take our second one, which says negative y minus 7z, and z is 5, is equal to negative 32. Negative y minus 35, bring it to the other side. 32 plus 35. Negative y equals 3, so y equals negative 3. And finally, x plus y plus z equals 4. X is equal to 2. So my strategy was to try and get the one I'm able to manipulate the easiest. I put that in row 1. Usually that's looking for a 1 in that top left-hand corner, because that's easy to manipulate. And then going from there until I get the first column all zeros, and then I'm able to get that. If we had a 4 by 4 matrix, you would get all 3 zeros first, then the next 2 zeros underneath that, and then finally the 1 0. So you would attempt to get these zeros first, then these ones, and then this one. So we'll do another one, and this is leading us towards the Gauss-Jordan elimination, which does the same thing, but also gets all 1s here and all 0s there. And once you do that, it's really obvious that, what's the letter after z? X is equal, y is equal, z is equal. A is equal, start over at the beginning. Or maybe we should have done A, B, C, and D. Not sure. Okay, so here's another one. Another 3 by 3. I'll pause the video for a second. Okay, there you go. Have fun. So one of the ways, if you're looking for your mistake, that you made a mistake and you're trying to find it, what you can do is use matrix, augmented matrix, into your calculator. I'll just make it a little smaller. So, second matrix, edit, 3 by 4, and we've got 2, 5, negative 1, negative 15. 1, 2, 3. Oh, did you switch? Did a lot of you switch row 1 and row 2? Okay, I'm going to just write it with the switched form. So 1, 2, 3, 4, 2, 5, negative 1, negative 15, 3, negative 4, 7, 26. So if we go to our matrix and we go to math, and there they have ref for reduced echelon form of matrix A. It'll put the zeros in there, and what it will actually do is do an extra step and divide each one so you for sure get ones. Okay? So math. I don't know if that's beneficial to have all those extra fractions there, but it will tell you that Z is 3. All they did was divide row 3 by whatever numbers you had at the end to make it a 1. And then they did the same thing with whatever number you have here. They divided that whole equation. It looks like it was 23, is that right? They divided that whole equation by 23 just to have a 1 to start with. But that's not necessarily or recommended. Okay. So we are going to get our first column of zeros. We are not going to change equation 1. 1, 2, 3, 4. We are going to get zeros here and here at first. So I'm going to have to change my row 2. My row 2 is going to be the row 2 that I have and subtract 2 row 1s. If I do that, I will get 0. 5 minus 2 row 1s will give me 1 there. Negative 1 minus 2 row 1s will give me negative 7 there. And negative 15 minus 2 row 1s will give me negative 23 there. If I want to get a 0 in the bottom left-hand corner, I'm going to have to change my row 3. My row 3 will be the row 3 that I started with, and then I'm going to have to subtract 3 row 1s. So negative 4 minus 3 row 1s will give me negative 10. Negative 10 minus, 7 minus 3 row 1s will give me negative 2. 26 minus 3 row 1s give me 14. Again, row 1's not going to change. These zeros aren't going to change, but I want to get a 0 here now. So in order to do that, I'm going to have to change my row 3. My row 3 is going to be my row 3 to start with, but then I'm going to have to add 10 row 2s. So my row 2 is not going to change either. Okay. And we're going to have, this will be 0. Now row 3 is negative 2 plus be negative 72. And here, oh, I forgot my negative here. Negative 230 plus 14 will be negative 216. And so what do we know now? We know that negative 72z is equal to negative 216. Z is equal to 3. 1 minus 7 times 3 is equal to negative 23. Looking at that one. Oh, 1. That was y, not 1. 1y minus 7 times 3 is equal to 21. Add 21 to both sides. Y is equal to negative 2. And finally, 1x plus 2y's plus 3z's equals 4. 9. And x is equal to -1. Woohoo! So you can make your own equations for practice. Choose a value for x, choose a value for y, choose a value for z. You can choose anything. I recommend not choosing fractions. Just makes your answer nice at the end to check. But you could choose fractions. Then you make up random equations, 3x plus 4y plus z, and then plug in your values and see what it equals to. And you could solve it from there.